In this video, we want to learn about the transpose of a matrix and how we can transpose a matrix. The transpose of a matrix is a new matrix that we can find it simply by interchanging the rows and columns. Let me show you an example. Suppose we have a matrix like this: 3, 4, -1, 2, 7, 8. This matrix is a 3 by 2 matrix because this matrix has 3 rows, first row, second row, and the third row, and has 2 columns. So this is a 3 by 2 matrix. The transpose of this matrix, which we usually show it with this notation, A superscript T, we show it with this notation, is a new matrix which we can find it by interchanging rows and columns. So for finding the A transpose, we have to make the rows of this matrix columns for this new matrix. So 3, 4 is the first row for matrix A, so it becomes the first column for matrix A transpose. -1, 2 becomes the second column, and finally 7, 8 the third column. Now look at the dimension, the size of this new matrix. This new matrix is a 2 by 3 matrix. What you can see between these two sides, the order is changed. In general, when we have m by n matrix, the transpose of that matrix, which we show it with a T, is an n by m matrix. For example, when we have 5 by 6 matrix, the transpose is 6 by 5. Let me show you some more examples of transposing a matrix. Consider this matrix: -1, 4, 7, 10, 1, 6. The transpose of this matrix is a 3 by 2 matrix because the original matrix is 2 by 3. We make this first row, first column for this new matrix, and the second row, the second column here. So as you can see, finding the transpose of a matrix is really simple. Let me show you another example. Consider this matrix, matrix C with elements -1, 2, 1. This matrix is a 3 by 1 matrix. The C transpose is -1, 2, 1, which is a 1 by 3 matrix. Here we have 1 column, here we have only 1 row. Also note that the transpose of a matrix is the same matrix. In general, if we transpose the transpose of a matrix, we get back to the original matrix, which completely makes sense, because if 2 times we switch rows and columns, we back to the original matrix. In the special case, if we have a square matrix like this matrix, for example, 2, -3, 4, 1, 6, 7, 5, 10, 9. If we transpose this matrix, what is that matrix? That matrix is 2, -3, 4, 1, 6, 7, 5, 10, 9. What happens when we transpose a square matrix is that, first of all, the elements on diagonal 2, 6, 9, the position of these elements doesn't change. Always these elements keep their position. So in a square matrix, the elements of diagonal doesn't change. and other elements reflect with respect to diagonal. If you pay attention, -3 and 1 switch their position. 4 and 5 switch their position, and 7 and 10 also switch their position with respect to diagonal. This is what happens when we transpose a square matrix. And in general, attention, when we transpose a matrix, if we have an element in the original matrix in ith row, because I shows the row number and j shows the column number of an element, when we transpose, what happens is that j becomes row number and I becomes the column number of that element. So we can consider this as definition for transpose. The position of the element changes with this relation. The number of rows and columns changes. For example, if we have an element in second or row, third column, in the transposed matrix, the position of that element is third row, second column. But because the elements are on diagonal of a matrix have the same row and the same column, so when we transpose those elements, so when we transpose the matrix, the position of those elements doesn't change. Note that when we have a square matrix, say 5, 6, 7, 8, what is the position of this element? This element is at position 1, 1, and this element is at position 2, 2. If we switch 2 and 2 and 1 and 1, nothing changes. So these two elements keep their position, but 6 and 7 change their position. I hope by watching this video, you have learned about the transpose of a matrix and how we can transpose matrices in general. If you like this video, please subscribe in my channel and thank you for watching.